So my name is Richard Wise, and like Aurelia said, I'm a senior research engineer at Georgia Tech Research Institute. So my day job really consists of applying MBSE tools, languages, methods, all that stuff to the analysis and design of complex, mostly electronic systems. That seems to be our bread and butter in our lab. So what are we talking about today? My temperament, my personality lends me to ask questions like why. When we're talking about MOSA, this is what this presentation is about. I have to ask why. Why should I care about MOSA? Why should you care about MOSA? Well, it's a good idea, right? Of course, we want things to be modular and open. We want plug and play capability. I want to be able to go and buy what I need from whomever I want. I don't want to be locked into a particular vendor. And we do this in our everyday life, except if you own Apple products like I do. But now, since 2019, it's the law. You have to if you're a major acquisition program. So here are some terms and definitions right out of Title 10, Section 4401 in the U.S. Code. Don't expect you to read all of that, but if you want to, on your own time later, you'll notice two major things that emerge from that. The first is modularity, and the second is standard interface standardization. So if you implement both of those in an approach harmoniously, then you reap the benefits, both from a technical standpoint and also from a business advantage as well. But, even though that law, you shall be MOSA compliant, is driven all the way from the top down, it's ultimately the responsibility of individual program managers in program offices supported by their systems engineers to decide on a particular approach. So the buck really does stop with a program manager who is supported by systems engineers. Okay, well, where do you begin? So part of my, preparing for this presentation, I came across the DAU website, very well written. It had to do with modular design, and they listed out, actually pulling from the Acquisition Workforce Qualification Initiative, 8 responsibilities of a program manager and an SE with respect to developing a MOSA strategy. So you see them there. The first two, or actually the first one deals with identifying open standards relevant to the program or the system. And the second one has to do with modularity based on those standards. And, reading through all that, that's very helpful. But PMs and SEs really need a starting point that's flexible for them, because it's not necessarily a one size fits all kind of approach. So they need flexibility built in. And obviously, we can't tackle all of those all at once. So let's just start with number 1 on their list of to-dos. Identify open standards that are applicable to their program or to their system. Well, according to the DAU website that I was referencing, and I'm not meaning to throw shade on DAU, is a very useful website, and the tool that they suggested to use to identify MOSA or MOSA enabling standards is Assist. Again, it's a great tool. It helps you identify standards, but it's much more involved than just typing in keywords and coming up with a list of standards. There are numerous standards available, many of which require in-depth technical knowledge. You really have to be an expert on a standard to know what it's talking about. At least that's my experience, but you guys are much smarter than I am, so you may get it if you open up one of those standards. Many of the standards and the requirements in them overlapping and compete or conflict with each other. And from the standards that I've read, if you're reading through a section, it's often presenting options. It represents a set of options so that if you have this, if these particular conditions are true for you or your system, then you choose this standard. Or if these other conditions are true for you, then you choose this standard. So that's great, but what happens if your system chooses one standard, that doesn't necessarily guarantee that another system, although it's implementing the same standard as a whole, is going to interoperate with that system if that other system chooses different standards options. They make different choices. Additionally, most of these standards are textual. So they're not model-based, although those different standard bodies are definitely working in that direction, and that's great. But because they are textual, that can lead to misinterpretations. I can read something, somebody else can read the same thing and get two different things out of it. That's just how it works, it seems. So a few other points is that each standard talks about things differently. They each talk about things uniquely within their own scope and within their own universe, if you will. And they also define terms differently. So one standard may define adherence or verification to the standard in terms of compliance, and another one in terms of conformance. And they mean different things. I screw up the definitions all the time and misuse them all the time. But, they do indeed mean different things, but it often depends on which standard you're actually looking at. So, what is an SE supposed to do with all this? Which standards and which parts are applicable to their system? How do they separate the wheat from the chaff? Do they have to be an expert on each and every standard that may be applicable to their system? How do they choose the right ones for them? How do they choose ones that don't compete? How do they select from different kinds of options? And for the choices that they make in those options, how do they have confidence that they're going to interoperate with other systems using the same standard but different options? And then finally, how does an SE decode all the concepts and terms into a coherent and consistent understanding? Well, I'm with GTRI, and we are here to help. So with this approach that I'm going to walk through, we first started thinking about, what are some basic use cases? We're all good systems engineers. So if we take our systems engineer as our primary stakeholder and user, not primary stakeholder necessarily, but user, what are their main use cases? And I'll go ahead and caveat this by saying our problem is scoped to modernization. A good bit of what we do has to do with modernizing systems and less with brand new start systems. So I just want to go ahead and lay that out. The problem may look different if we're dealing with a brand new greenfield kind of system. So those two use cases. Now, if I were to read this, I would say a systems engineer uses the standards identification approach in a modernization case to identify specific applicability of specific open standard requirements to common architecture elements. And then the second use case is like a natural consequence of the first. So a systems engineer wants to use the standards identification approach to provide traceability and evidence that their system is going to meet minimum interoperability, and that's defined by SMEs within a given domain via standards application. So if they choose the right standards and apply them in their system, then they're going to meet that minimum interoperability. So when we began analyzing those use cases, several challenges emerged from those. The first is, well, how do we normalize and unify all of those concepts from the given standards into a single thing? From one standard, it identifies a doohickey in there. And then if you look at another standard, it's a thingamabob. But conceptually, when you read into it and try to really understand what they're talking about, they're both talking about a doodad. They're talking about the same thing, basically, even though they use different concepts, different terms. It's the same thing. So we needed a way to be able to unify and categorize all those into common, ubiquitous, well understood concepts that are cut across domains, cut across industries, and what have you. The second is to create a foundation for all of those standards to work together to a level of commonality that's applicable across the enterprise for all the systems in the enterprise within a given domain, and if possible, even abstract that domain into a higher level so you have even broader commonality. Third, we have to bake in flexibility. We want program offices to be able to choose the right standards that make the most sense to them. Fourth, we have to provide confidence that program offices are going to be better off and they have that traceability and evidence for meeting that minimum interoperability requirement. And then finally, we have to make it reusable. We don't want to be bound to a specific capability domain nor specific system for that matter. So we want to make sure that the approach is generic enough and tailorable enough where it can apply to many different domains. So this is what we came up with. We call it the Standards Identification Reference Architecture, and it's a UAF fit-for-purpose architecture designed to identify standards that are applicable to systems within a given domain. So all the sub-bullets you see there are really just addressing the questions that I've already talked about, so I won't labor on that too much more, and I've got a lot of slides to get through. So the conceptual model underpinning the reference architecture is really simple when you look at it. It is focused on two major themes, a minimally constraining common system description, and then prescribed standards that are there to maximize commonality among systems within an enterprise and within a given domain. So if we start up at the top, we see capability. We establish what the capability is within the given domain, something like electronic warfare, for instance, or electronic support, maybe as a subdomain. I've worked on electronic warfare systems before. So that's my example. And then those are exhibited by some kind of system, like an electronic support system, just very high level, very generic. And then that's decomposed into a number of subsystems. Those subsystems really just represent logical groupings of functionality. We're staying really high level here. And then those subsystems are supported by, notice not decomposed by, as semantic nuance I'm trying to make sure is conveyed here, by standards categorical elements. And those are those things, those common ubiquitous concepts that cut across standards that are there to help normalize individual standard requirements from the set of prescribed standards. And then those standards categorical elements, although I don't have a relationship there explicitly called out, they are conform to or comply with individual consensus-based standard requirements pulled from that set. And with those requirements, they also have many different kinds of relationships themselves, two of which we can go ahead and identify, although there are more, one of which is what I talked about before, where the requirements may present options. So you may have a relationship like choose between. And then another one is called depends on. So there are inherent and maybe even explicit dependencies between these requirements. Another one might be conflicts with or competes with or overlaps with, although that's more complicated and we haven't really had time to think through the full implications of that yet. And then lastly, a requirement is characterized by a must-use flag. So from SME input, both standards, SMEs, and domain SMEs, there has been some kind of determination on what standards, what individual requirements or clauses or sections within these prescribed standards have to be used within an architecture in order to meet that minimum interoperability. And this changes according to whatever domain you're in. But still, it's the same basic concept. And this must-use flag is really important when we're talking about adherence or compliance with or conformance to this reference architecture for any architecture, like an objective architecture that aims to map to and use this reference architecture. Okay, so great. How does an SE actually use it? They have a lot of different concerns. It may be where, and the truth is that only certain parts of their architecture are concerned with complying with standards. Not every single element of their architecture aims to comply with the standard. So how do they go about discovering and identifying the relevant standard requirements? How do they know if they're using the reference architecture the right way? And how do they know if they're any closer to MOSA compliance after they use it? So it's actually larger than what I expected, but still, it's kind of an eye chart. Don't expect you to all to be able to read that necessarily, but it's the full conceptual model behind what we call the standards identification reference architecture adherence framework. Trying to come up with a cool acronym for that, but we're not there yet. So over on the left is the previous diagram that I showed you with a conceptual model of the reference architecture. Over on the right is just a super simplified representation of a referencing architecture, like one that might be developed by a program office, either an objective architecture or a system architecture. And then in the middle is the glue. It's the glue that helps map a referencing architecture, a program office architecture, map to the reference architecture. And there are 5 basic parts of that mapping, and we call it the standards identification reference architecture adherence view. So again, another opportunity for a cool acronym. But those 5 main concepts are profile application, resource alignment, standards identification, adherence verification, and then adherence quantification. So 5 basic components. When this is implemented in a tool, it looks something like this. Those 5 packages with their contained auto updatable magic under the hood, smart packages, and pre-configured matrices and tables, they help to guide a systems engineer through exposing only the relevant architecture elements that need to comply or map to an open standard requirement. It also helps them by asserting capability and functional alignment, and this aids in information discovery. Third, identifying relevant and applicable standards, helping them to choose among options to present the information in a way where it's easier for them to choose the option that makes the most sense to them, giving them the ability to declare exceptions to required standards because we want to give them flexibility. Next is analyzing, how well did they trace to the reference architecture? So some degree of verification, and then finally, actually quantifying and running analyses on adherence to the reference architecture. All right, so let's go. Let's see it in action. The reference architecture is intended to be used as a read-only module in a program office or a referencing architecture project. So once that's done, then this adherence view, the glue, is just copied and pasted into the target architecture. It's really as simple as that. So the first step in this mapping and applying this adherence view and mapping to the reference architecture is to identify things in the referencing architecture that need to map in the first place. The first thing we have to do is, basically tell the adherence view that this referencing architecture is indeed mapping to the standards identification reference architecture. We have to tag it so that the adherence view knows what to do with the information contained in the referencing architecture. Next, we have to identify the elements, and specifically those modular components. Thank you. And interfaces that need to comply with the standard, because not every single component in a modernizing system architecture needs to comply with the standard, and not every single interface needs to comply with the standard. Not every interface is aimed to be made open. So we have to go through and give the ability to apply the stereotypes. You can use subclassing. That's another kind of method. I chose stereotype application to do that. So apply the stereotypes. Align So once those stereotypes or those elements have been identified, we have to go through and begin to align our referencing architecture or program office architecture to the reference architecture. And this is because the reference architecture itself, the capability that it's covering may be broad, and it may encompass a superset of capabilities, in which case the reference architecture, I'm going to get that confused here. Referencing architecture needs to pick the system that matches the best, or the system out of the reference architecture that matches the best with what they're actually doing. So in a referencing or program office architecture, if they're developing a new electronic support kind of system, whatever it may be called, they need to map to an electronic support system in the reference architecture for capability and functional alignment. And then the same thing is true for all of the key components and interfaces in the target architecture. I'll just call it that. They need to identify and align with subsystems that perform the same basic functionality that's in the reference architecture. And it's important to note that not all subsystems in the reference architecture are going to be aligned to the program office or target architecture. We're not allocating functionality from the reference, the standards identification reference architecture, to an objective architecture. Rather, we're doing it from the other way. We're doing it from the target architecture perspective. We're trying to just make sure that we're aligning those two architectures from a capability and a functional perspective. Next, identify the applicable standards. We have to map those key elements, key components and interfaces to standards categorical elements that really encompass and embody a collection of standard requirements, and map to the ones that are logically and physically similar. And then we have we have constraints in place that ensure that those key elements aren't mapped to those categorical elements that aren't in the same subsystems. This is part of that functional alignment. Because if it were to map to something outside of similar subsystem, then it would be considered an invalid mapping. It wouldn't quite make sense. Lastly on here, kind of a bumper sticker, is that we can't know everything in the reference architecture. So there are going to be some elements within a target architecture that won't map. There's just no categorical element nor standard that really fits with their either interface or system component, and that's okay. I'll get to that in just a minute. Talking about choices, so we give the ability for an office to choose the right standard from among a set of options, and sometimes that may bring other standards along for the ride because of inter and intra standard dependencies. So I'm going to breeze through this quickly here. 5 minutes, thank you. All right. There may be some standards that, like I said, don't map to one identified in the reference architecture, but they still have to comply with the standard. So then at that point, it's up to the systems engineer and the program office to pick the standard that makes the most sense. Here, we talked about declaring exceptions, because not every standard in the set of those that are deemed as required or you have to use them actually make business and technical sense. It could might be detrimental to the program even if a particular standard is chosen. So we have to give the flexibility for a program office to declare an exception, and it's done through that matrix there that you see. And the table underneath provides the ability to give a justification as to why. So it could result in a significant cost and schedule increase, or as a systems engineer, I just don't agree that this requirement actually aids in minimum interoperability, so I'm not going to use it. So when all that's done, a systems engineer can view all of the information in a single view, or visualize all of that information in a single view. And then over on the far right column, So every row represents one of those key elements, a modular component or interface, and over on the far right are the standards that are applied to the system. And each application of a standard really represents a derived requirement. So through some not too complicated scripting or macro, you can auto-generate requirements that can be placed into an RFP. So this, in my opinion, is better than the requirements that I've seen in the past where it's just a single line, the system shall be MOSA compliant. So I think this can really help systems engineers. Next, we can run analyses to see if the mappings have been done correctly, and then actually quantify the degree of adherence. So we measure adherence as the ratio of the number of excluded must-use requirements by the total number of must-use requirements. And in this simple example, we only have 80% adherence. And maybe that's okay. And that's really up for the program office to decide if 80% is okay or not. So we're going to say it is. So we're all good. We can ride off into the sunset. And, we're almost there. It's a wild and crazy ride, but at least we know the way. But, if you were paying attention during Laura's talk just before mine, you may be asking, or you want to ask a question like, Richard, isn't this a domain overlay? Laura just laid it out for us. What are you doing? Well, yes, it is. I love Dwight. And isn't it ironic? But we did develop it independently. So in full disclosure, I knew about analytic view overlays then. Okay, all right, almost done, promise, maybe. But we took different paths to get there. I really did develop it in ignorance, honestly. So I'm not going to belabor this. Laura did a great job in explaining what a domain overlay is. So I'm just doing a side-by-side comparison of the two, and hopefully you can connect the dots yourself. So characteristic 1, check. 2, check. 3, check. 4, check. 5, check. And that's it. So in summary, we still have a lot to do. There's a lot more questions we need to answer. We need to address, new start systems. The adherence framework can be applied to any capability domain. It's not specific to one. I'd like to see if the basic approach itself can be generalized for other concerns besides MOSA. Maybe it can. The adherence framework is a domain overlay, so it quacks like one. So it is a domain overlay. And I'd also like to say that the domain overlay itself is intuitive, and if I stumbled across it, others would. So I'd say it's naturally discoverable. And since I'm in the UAF Summit, I'm going to give a shout out to UAF. Once I wrapped my head around the UAF grid, it actually made thinking about the problem easier, believe it or not. And then the modeling language provided a much richer vocabulary and semantic foundation to build off of when architecting the framework. All right, that's it. I'm done.
All right.
Hey, Richard, great brief. Really enjoyed it. Did you think about risk or sustainability when you were looking at just MOSA for adherence? Because it's more, I could say that the KPP for NetReady is mandatory, right? And there's no incentive to go past that unless it's mandated, like you said, for an NDAP. So did you think about, one, expressing risk to the PM, maybe using UAF, and then expressing sustainability? Because to me, it's more than MOSA, it's a sustainability and vendor law. And then second, maybe updating the standards registry library at some point that Cameo offers.
All I was going to say is there's some work that's being done right now looking at
most MOSA use cases, why are you, what's the purpose of applying MOSA, and then also looking at the metrics that would be associated with that use case. And then once we really get that back in the MOSA guidebook that we're expecting as well, we can start updating some of these DOs to capture the metrics and the concerns that come to us from the government. So that's how we're addressing their concerns. You asked that question earlier.